Hello guys, I'm back. Some days ago I told you that there are at least two improvements to be done in this process flow diagram. And today I will share with you my comments. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and my mission on internet is to help you how to work with plant design. And to do that, one of the most thing or the first thing that you must do when you get a new process to evaluate a process flow diagram, a heat in material balance, is look for consistency, or if there are any inconsistencies in your documentation. So based on that, you can see here that we have a process where I get the biogas, compress that on two stages, where one of these stages receives a recycled stream from the flash tank. This compressed biogas goes to absorber column where CO2 is removed. It's not my objective here to detail the design. I will do another video about that. But this process simulation was performed on Aspen Plus, and it is possible to identify based on the graphs of the drawings, how the drawings were developed. And what is most important here is what is happening that can be improved in this process simulation. So let's think, every time that you are doing a process simulation, you must think about the field, about real life. What happens in real life when I do a process simulation? So based on that, let's see the first issue that I believe that can be improved in this process simulation. So verify that the recycle stream goes to the suction of the second stage of the compressor, and it mixes with the discharge of the first stage of the compressor. So what we have here? At the discharge of the compressor, the pressure of the biogas is 5 bar. So it is 5 bar, goes to the suction of the second stage. However, the flash tank operates at 3 bar. It means that the vapor phase of this tank at 3 bar returns to the suction of the compressor. So there are two things that can happen here. The first one is if the discharge of the first stage of the compressor is 5 bar, I will seal the vapor phase of the flash tank, because the vapor phase of the flash tank is 3 bar, and I will not have enough energy to let my fluid going through the pipeline. But another way that I can think about it is that besides mixing at 5 bar, I can decrease the pressure from 5 to 3 in order that I am able to mix the streams. But these do not make sense because I will be losing 2 bar of pressure and losing energy. It's important to you understand that different from temperature, where we have the mix of fluid and we get an average temperature or an average result, pressure, it's not possible to mix 1 bar fluid with 5 bar fluid and have the 7.5 bar as average pressure. That is not the way that happens. A fluid with a higher pressure tends to seal a fluid with a lower pressure. If we are talking about a system where the largest pipeline or largest header runs or operates at low pressure, the higher pressure fluid will be able to go inside to the lower pressure fluid, and you will not have the increase in pressure, because most often the high pressure fluid has a very low flow, and it will not be significant to increase the pressure above 3 or above the lower pressure operating pressure. If we are talking about the opposite, if I have a large flow of high pressure and I want to mix with a lower flow a small flow of lower pressure, the gas will be sealed and I will not be able to mix them. So what will happen here in terms of operating is, as I don't have enough pressure to mix the gas in a steady state condition, eventually my gas will be blocked until the vapor phase of the flash tank reaches 5 bar, and I will have a gulf of gas to mix in the suction of the second stage of compression. And with that, I will not have a smooth operations, I have disturbance, I will have issues, and I will not get the performance of the plant. So the first thing here that I would improve in this process simulation is reduce the pressure at the discharge of the first stage of compression. Because if I have 3 bar here, in terms of heating material balance, makes sense to mix a 3 bar fluid or recycle stream with a 3 bar discharge stream, and with that have the suction of my second stage of compression. So this is the first improvement that I have seen from this process flow diagram. The second thing is in the stripper column. Verify that the stripper column operates at 1 bar and 20 Celsius degree. And the bottom of the stripping column, it's a liquid fluid. It is splitted, or we have a purge here because the objective of this stripper column is to regenerate the water that is recirculating in the system. So I have a purge, and part of my liquid, my water, returns to the absorber column. But the absorber column operates at 10 bar, and my stripper column operates at 1 bar. So I have 9 bar of differences, and how I am able to fill my absorber column from the stripping column if I don't have a source of energy to increase the pressure of the stripping fluid. So in this point, what must be added to the process simulation is a pump at the bottom of the stripper, because the pump will be responsible to getting the liquid at 1 bar, increase the pressure for at least 10 bar, and with that be able to do recycling of the fluid. But it's important to understand that the discharge pressure of the pump will depend on the age of this column. Eventually, even though the absorber column operates at 10 bar, but let's suppose that the age to the fluid going up to the absorber column is 15, 18 meters, I must consider the 10 bar plus the age of liquid needed to do the recirculation of my fluid in this process. So based on that, as I'm not considering a pump to my process, I am not considering the energy needed to do this increase in pressure. And in my summary, utility summary, when I inform the consumption energy or electrical consumption for the maintenance, for the management, for the feasibility study, I will informing a lower energy than will be used in the field. Or if for any reason someone during the detailing design, the basic engineering, forget about adding the pump here, it will not work. So these are at least the main improvements that I identified in this process simulation. If you have identified others, please share in the comments, because all the community will be able to learn more from this video. So guys, this is it. I hope you like it, and I'll see you soon in the next video. Bye bye.